Let us consider a problem which is based on calculating the circular convolution of two given sequences. In this problem, the value of x of n is given as 1, 2, 3, 4 and the value of h of n is given as 1, 2, 2. Now, in a problem which is based on the circular convolution, it is important that both the sequence should be made the same length. So we observe that the length of x of n here is n1, which is equal to 4. The length of h of n is n2, which is equal to 3. Therefore, the circular convolution length is given by capital N, which is greater among the two. So maximum of 4 and 3 is 4. So n is chosen to be 4. Now, the length of h of n, which is shorter, it is 3. We can pad a single 0 and make it length 4. Therefore, it becomes 1, 2, 2, 0. Now, first we follow the method for solving the problem, which is called as the time domain approach or the concentric circle method. So the time domain approach uses the formula of the DFT. Therefore, from the definition of circular convolution, it uses the formula of circular convolution. From the definition of circular convolution, y of n is equal to x of n convolved with h of n, and we know the formula is something like this: summation m between 0 to n minus 1 x of m h of n minus m mod n, and the n value is between 0 to n minus 1. Now, since the problem is for n is equal to 4, substituting the value n is equal to 4, we get m is equal to 0 to 3 x of m h of n minus m mod 4, and the n value is between 0 to 3. Therefore, now if you expand this particular summation, we get 4 terms as shown here. So first we have x of 0, x of 1, x of 2, x of 3. These are the inputs. They are multiplied with the h of n, where we are taking mod of 4. Next term is n minus 1, next is n minus 2, last is n minus 3. Now, substituting the value of n, so let's take the first number, that is n is equal to 0. When you insert the value, you get the term h of 0. Here we get h of minus 1 mod 4. Then we have h of minus 2 mod 4. Then we have h of minus 3 mod 4. Now we have learned how to apply mod. When you have a negative value, you have to add 4. Therefore, it becomes h of 3. Minus 2 becomes h of 1. Minus 3 becomes h of 1. So then substituting the corresponding values and simplifying, we get the answers 15. Similarly, if we want to proceed to the next term, n value is equal to 1, then what do we observe in the formula is that when you insert the value n equals to 1, we have to add 1 to the index. Or we can say that each value is incremented by 1. Therefore, to avoid any complication, we can quickly tell that the x terms or the input x will remain in the same place, whereas the second term, the index is going to change. So we get what is called as h of 1, h of 0, h of minus 1 and h of minus 2. This is what you get when you substitute the value n is equal to 1, which simplifies in a very simple fashion, giving you the value of h of 1, h of 0, h of 3 and h of 2. Alternatively, in a very easy way, you can perform what is called as a right shift. But when you're doing right shift, you have to shift it circularly. That means the last point here will now come to the first place. Then correspondingly each element is shifted. So if you do circular shift, then you probably will end up with the set for each different value of n. Now substituting the number and solving, you get the answer is 12. Similarly, if you proceed for n is equal to 2, also you can substitute and you get the answer. So this has to be done for different values. N is equal to 0, n is equal to 1, n is equal to 2 and n is equal to 3. Now Let us represent the two sequences in the form of circle. We'll just see how it is done. If you take a look at the expression for n value is equal to 0 will become x of m into h of minus m, because n value we have taken is 0. Therefore, x of m, if we are writing on the inner circle, and the convention we are following is a direction which is clockwise. So the numbers are 1, 2, 3 and 4 for x of m. Meanwhile, we have h of minus m. Since the sign is minus, therefore we will write out this sequence in the reverse direction, reverse to what we have taken for x of m. Therefore, the values are written as 1, 2, 2 and 0. Now, multiply the respective terms 1 into 1, 2 into 0, 3 into 2 and 4 into 2. We get the same answer, which is 15. To proceed for the next calculation, keep the inner circle fixed. Don't change the inner circle. But for h, we'll get an extra value which is 1. We have h of 1 minus m. So this is nothing but shifting 1 unit in the clockwise direction. Since we have a plus here, the direction taken here will be in the clockwise direction. So therefore what will happen, since you are rotating it in clockwise direction, the value, see 1 will come here, the value 2 comes here, like that each element is shifted in one step in the clockwise direction. So again we perform the corresponding multiplication and the sum of that is the result, which is 12. Like this we can proceed and we can compute all the values. Now after you get the result, you can do a quick check of what you got is right or wrong. For this we can employ a shortcut method which is called as a matrix method. So the two sequences are given. You take any sequence, express it in the form of n cross n. So the sequence 1, 2, 3, 4 is chosen here. To generate n cross n, we'll take the last element 4, place it at the top, and correspondingly the remaining elements are 1, 2, 3. Again 3 is moved to the top and then you have 4, 1, 2. 2 is moved to the top, then you have 3, 4, 1. And we multiply this with the other sequence which is 1, 2, 2, 0, and the answer you get after simplification is 15, 12, 9 and 14. So same answer should have been obtained when you follow the time domain approach also. The second approach of solving the circular convolution is using Stockham's method, which involves the DFT and IDFT equations, or it's a transform domain approach. So we are aware that y of n is x of n convolved with h of n, where this is circular convolution. When you apply the DFT on both sides, we get y of k is equal to x of k into h of k. This comes from circular convolution property. Therefore, to get the answer for y of n, first we have to compute the DFT of the input x of n, then we have to calculate DFT of h of n, multiply the two respective DFTs, the result will be y of k. Then taking its IDFT, we get the answer y of n. Let's start with the first step. To solve for the DFT of x of k. The DFT of x of k, using matrix notation we are doing it. So x of 4 is equal to small x of 4 into w4. So the inputs are expressed in the form of a row. So the 4 elements are 1, 2, 3, 4. Here is the twiddle factor matrix. On performing multiplication, we get the first set of answer for x of k as 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Similarly, to find h of k, using the matrix method, we have the input 1, 2, 2, 0 into the twiddle factor matrix. The solution for that is 5, 1 minus 1 minus 2j, 1 minus 1 plus 2j. After finding the DFTs, the next thing you have to do is to find the product. Therefore, y of k, which is equal to x of k into h of k, is the element wise multiplication. So the respective elements 5 into 10. Next you will have complex numbers. So when you have complex numbers, be careful when you multiply and simplify the value. The result of this element-wise multiplication is the values 50, 6 plus 2j, minus 2 and 6 minus 2j. To find y of n, we have to take the IDFT of y of k. Again using matrix method, we have 1 by n y of k into wn star. Therefore, 1 by 4 times the sequence that we just obtained into the twiddle factor. But please note the twiddle factor matrix is conjugate. Therefore, we have plus j and we have minus j here. Again, performing the respective multiplication, the result we get is 60, 48, 36 and 56. Dividing throughout by 4, the answer you get is 15, 12, 9, 14. This matches the result of the previous method as well as the verification method. Now, the variants that you can get on the convolution problem in the examination is, you may be given an expression, like for example, they'll give you sine of something and say that you have to calculate for n value which is from 0 to 3. So it is very simple. When you're given an expression, all you have to do is substitute the different values of n, generate a sequence like we had in this problem. So once you get the 4-point data sequence, it's very easy to calculate the circular convolution using any method. So in the examination, please check the method. They may mention perform using time domain approach, or perform using frequency domain method, or using DFT IDFT, or say Stockham method. So looking at the method, you have to follow and get the answer for circular convolution. Let us look at the next problem. The problem states a 498-point DFT of a real valued sequence x of n has the following DFT samples. The samples provided are x of 0, x of 11, x of k1, x of 112, x of k2, x of 249, x of 309, x of k3, x of 412, x of k4. The other samples have a value 0. Find the value of k1, k2, k3 and k4. The important points to note in this particular problem is, first, the number of points is mentioned as 498. The input sequence is said to be real valued, and there is some sort of symmetry exhibited by real valued sequence. So we observe that some of the points here are complex conjugate of each other. Now, keeping these things in mind, the objective is to calculate the value of k1, k2, k3 and k4. So from the given, we observe that the input is said to be real valued, and real valued sequence have a symmetry about their DFT. The symmetry condition is given as x of k is equal to x conjugate of n minus k. Now, considering the value of n, which is equal to 498, first let us evaluate the value of k1. Now we observe that the point which is matching with the value of minus 2.2 minus j 1.5 is the x of 412, which is complex conjugate of that. So let us begin with that particular k value. So taking k value as 412, if you substitute the value of n and k in the above equation, we get x of 412 equals x conjugate of 498 minus 412, which is equal to x conjugate of 86. Therefore, x of 86 is equal to x conjugate of 412. We know the value, and if you take the conjugate, then this value is similar to the value that is x of k1. Therefore, we can establish that the value of k1 is equal to 86. To proceed to the next point, we substitute the value 309 because 309 is identical to the conjugate of k2. Therefore, using the value k is equal to 309 in the relation, x of 309 is equal to x conjugate of 498 minus 309, simplifying gives you x conjugate of 189, or x of 189 is same as x conjugate of 309 equals minus 4.7 plus j 1.9. Therefore, the k2 value is 189. Next, taking the value of k is equal to 112, substituting x of 112 is equal to x conjugate of 498 minus 112, that is x conjugate of 386, or x conjugate of 386 is equal to x conjugate of 1112 by taking conjugate on both sides. This value will be equal to 3 minus j 0.7, which is the value at x of k3. Therefore, x of k3 should be equal to 386. The last point is obtained by putting the value of k is equal to 11. So substitution will yield x of 11 is equal to x conjugate of 498 minus 11 equals x conjugate of 487, or taking conjugate on both sides, x of 487 should be equal to x conjugate of 11, which is equal to 7 minus j 3.1. It's same as the value of x of k4 given in the data. Hence, k4 value should be equal to 487. So here was a simple problem which is based on the symmetry property of a real valued sequence.
Thank you all.